Okay, today is day 7. We are going to talk about midpoints, finding midpoints between 2 points in a Cartesian plane. And we are also going to talk about the number of solutions to a system of equations. Today's kind of it's not a big learning day. Today's kind of like to consolidate what we've learned so far with systems of equations, because tomorrow you're going to have your bigger quiz. So what you need to do today is just do a little bit of this learning and then do some studying for tomorrow's quiz. I will cover the key points, again, finding midpoints and then finding the number of solutions to systems of equations. Let's get to it. Okay. First of all, we're going to talk about midpoints. So what is a midpoint? What is a midpoint? A midpoint between the midpoint of 2 points is the point exactly in the middle. Right? So it's equal distant from both points, and it's actually on the line between the 2 points. Okay, so like you may be able to find, there might be some point up here that if you drew a line, it's the same distance between here and between 1, 1 and 9, 5. But you're actually looking for the point that if you draw a line between the two, it's exactly in the middle. You want the exact middle, and you want it on the line between the 2 points. So with that in mind, let's talk about what that point is and how you find it. So let's just make a line. Okay, so we're going to make a line between the 2 points. And we know that our answer is somewhere on this line. Now, rather than proving to you the answer, I'm going to show you where the answer is. And that's going to be halfway. If we find the x distance from here to here, and we go halfway, and if we take the y distance here, and we go halfway, and then we find, the point on that line, right here and here. And what have we done? Well, if this point here is halfway from here, if this x point is halfway from 9 and 1, from, this 9 is x, the second point's x coordinate, and 1 is the x coordinate of the first point. 5 is halfway between 9 and 1, right? So what we do know is we know that halfway would place a point that's 4 away from 5, from 1, and then it'd be another 4 over from 5 to 9, if we're just looking in the x direction. Similarly, if we're looking in the y direction, if we start at 1, which is our y coordinate here, and we go 2, 3, 4, 5, 3 is halfway between our y coordinates of 1 and 5. Okay, so our midpoint, we think, then is 5, 3. It's the midpoint of your x coordinates and the midpoint of your y coordinates, and it looks to be about right. But why is it exactly right? Why is it right? Is because, as you can see, we have 2 triangles that are exactly the same size. Right? We've basically done a triangle that has a 4. 2 triangles with one side of a 4, and then the other 2 sides are 2, and they're both right triangles. So we know then that the other side, because these triangles are the same size, these have to be also the same distance. Okay, so basically this is kind of an informal proof of how you find the midpoint. You basically take the average of your x coordinates, and that's going to be your midpoint, the x coordinate. The midpoint of point 1 and point 2 is equal to the average of your x coordinates the average, you just add the two together, 9 plus 1 over 2. 9 plus 1 over 2 is equal to 10 over 2, which is 5. That's how you find your average. That's how you find the midpoint. And then the same thing for y. y1 plus y2 over 2. You're taking the average of your y coordinates, which is 1 plus 5 over 2, which is equal to 6 over 2, which is equal to 3. So that's our y, and that's our x. So we get 5, 3. Okay, so we've kind of done an informal proof here, and then we've written our midpoint formula. Now, I'd rather than try and memorize x1 plus x2 over 2, it's really great if you can really just memorize the kind of the key thing that you're doing. You're finding the average of your x's, and then the average of your y's. That's really what you're doing. If you get all hung up in trying to memorize the formula, x1 plus x2 over 2 and comma y1 over 2, you might forget, is this a subtraction or a multiplication? Is it x1 plus y1 over x2 plus whatever? If you just remember it's the average of your x's, the midpoint of your x's, and the midpoint of your y's, which is the average, I think you're going to do a lot better. Let's move on to some examples. So here's 3 examples. We want to find our, and I'll just draw them up here one at a time. So we're going to find the midpoint of 4, 6 and 2, 0. And so if we remember, we want the average of our x's. That's going to be 4 plus 2 over 2, comma, average of our y, 6 plus 0 over 2. So that equals 3, 3. That looks about right? It's the midpoint of our x's, and it's the midpoint of our y's. Okay, so this was 4, 6. The midpoint is 3, 3, and our other point is 2, 0. Okay, now let's move along. Now we want to do it in another midpoint. So let's do our midpoint formula. I recommend at this point you pause and try. Pause and try both of these. And I'm just going to draw them up here. And then we'll do our orange. But you should be giving it a whirl yourself. Okay, now I assume you've tried it. You have your work at home, but I will solve it with you or after you to confirm what you know to be true. Now, notice that the midpoint of our x's appears to be on this. If we look in the middle, it looks like we're on the 0 line. We're on the y-axis. So hopefully, when we do our average, -2 plus 2 over 0, we get 0. And it looks like that's going to be true. -2 plus 2 is 0 over 0. So our x-coordinate is 0. Now let's do our y-coordinate. Well, if it's 6 up to 10, looks like 8's going to be in the middle, but let's do our math. 6 plus 10 over 2, 16 over 2 is 8. So we get 0, 8. Now finally, let's do our orange points. Let's just do the formula first and then come back and plot it and see if it looks right. -4 plus 2 over 2, comma, 7 plus a -2 over 2, right? 7 plus a -2 over 2, the average of 7 and -2. So this is going to be -2 over 2, comma, 5 over 2. And that's going to be, keep going, -1, comma, 5 halves. So let's take a look and see if that looks right. -1, comma, 5 halves. 5 halves, this is also -1, comma, 2 1/2. So -1, comma, 2 1/2. That looks about right. Let's make sure that it's on the line. It better be on the line between the two of them. And it is. And it better be halfway between. So let's kind of look and make sure that that looks about right to us. Let's see. So between here and here, our midpoint 1, 2, 3, 4, 5, 6. Halfway is going to be here, 3. And then here, halfway 1, 2, 3, 4, 5, 6, 7, 8, 9. Halfway is 4 1/2. 1, 2, 3, 4 1/2. Yeah. So there's our midpoint, and it looks right. Forgot to box one of my answers. Let's box that guy. And it looks like we've found our midpoint. So hopefully this all makes sense. Sometimes our midpoints are fractions, even when our points have all integer coordinates, right? But we have found all 3 midpoints of all of our lines. Good. All right. Now I want to go to the second key point of today's new learning in today's lesson. And that's the number of solutions to a system of equalities. Now, when we talk about a system of equalities or a system of equations, we talk about having one solution. Because usually, if we have a line going like this and a line going like this, almost all lines will cross exactly once on a Cartesian plane. And so this is our one solution to the 2 lines that go one like this and one like this. So those are our two linear equations that are represented here graphically, and they have one solution, which will be a point. Like in this case, it'll be 1 1/3, comma, whatever, 1 1/2. That's our solution. It's this point. It's the point where they cross. Okay, now I'm going to erase it. Now there's two key points that I'd like to make. There's 2 other kinds of equations or sets of lines that don't cross once. So let's look, for example, at these 2 lines. And we know how to graph them. Y equals 2x minus 4. 1, 2, 3. This is minus 4. And so we graph that up 2 over 1, 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 up 2 over 1. Go the other way, back 1, down 2. And let's just graph that guy. All right. Now let's graph y equals 2x plus 1. Here we go. We got 1 here. That's our y-intercept, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up, down, go backwards, down, back 1, down 2, back 1, down 2. And let's draw our line here. Uh-oh. All right. Okay, so now we have these 2 lines in space. Now the interesting thing is, let's look at these points. Let's look at these 2 lines and see if they're ever going to connect. And I say that they're never going to touch, because right here, 1, 2, 3, they're 5 apart right here, right? 1, 2, 3, 4, 5. They're 5 apart. Here, they're 5 apart. 1, 2, 3, 4, 5. 5. Here they're 5 apart. 1, 2, 3, 4, 5. So we have these lines that are all 5 long, and we'll show that these lines are never going to come. These lines, these red lines will never come together. And what's the problem? The problem is that they're parallel. And we know that they're parallel because parallel lines have the same slope. So these lines are parallel. Parallel lines, and they never meet. Okay, that's an important key point. Now, the slope, so if our slope is the same and the y-intercept is different, then we have parallel lines and the number of solutions. Remember, the solution is where they meet, and these lines never meet, so there's no solution. There's no point that will make both of these true. All right, now let's talk about these two lines here. These two lines are interesting lines as well. So let's put this in slope-intercept form. This one here I know how to graph. Let's look at this line. There's something interesting about this line, and we'll see it in a second, relative to the other line. So let's see, 3y equals negative 2x plus 6. Now I divide everything by 3, and I get y equals negative 2/3 x plus 2. Well, this turns out to be exactly the same line as this one. So these lines are also the same line. So let's look at that. Plus 2, let's graph them. Plus 2, down 2 over 3, down 2 over 3, down 2 over 3, back 3 up 2, back 3 up 2. Okay, let's look at this. It turns out that these lines are the same line. So if lines have the same slope and the same y-intercept, right? They have the same y-intercept, and they have the same, include the negative sign, Mr. Lipscomb, negative 2/3. They have the same slope. These are the same. They're not parallel lines. They're the same line. And they have infinite solutions because this point, this point, this point, this point, this point, every single point on the line is on both lines. So we have an infinite number of solutions. Any point that makes one line true will make the other one true because it's the same line. So, for example, 0, 2 works for both equations. 3, 0 works for both equations. But so does 6, negative 2 works for both equations. And so any point, as well as this point, and this point, and this point. Okay, so what can we say about most lines, or most pairs of lines? Most pairs of lines that cross in space, and I think you can kind of see this, is that they have different slopes. If a line has a different slope, it doesn't matter how close the slopes are together, they will eventually meet at some point. Okay, so slopes that have lines, if two lines have slopes that are different, then the y-intercept can be the same or different, doesn't matter. But if two lines have different slopes, they will intersect one time. And I think we did this more in class. And so the number of solutions is 1. So two lines will either intersect 0 times if they're parallel, 1 time if they have different slopes, or if they're the same line, they obviously have lots of points in common, and in fact, infinite number of points, because there's an infinite number of points on any given line. Now let's look and use our chart here. Let me, maybe I'll copy this chart here. And we'll put this on the next page. Oh, we've already copied it. So if we have the same slope, same y-intercept, it's the same line, infinite solutions. Same slope, different y-intercept, no solution. Different slope, then they intersect once. So why don't you pause and try if you're feeling comfortable with this. I recommend you pause and try. But if not, we'll do the first one together. So let's do an analysis of whether, we're not going to necessarily find the intersection point, although you know how to do it. Let's look at these two lines and do our analysis. So let's put them in point slope form. No, not point slope. We're going to put them in slope intercept form to analyze. Okay, so let's do that for this one. Here we're going to subtract an x from both sides, and we get y equals negative x plus 8. This one's already in slope intercept form. So here we have the slopes are the same. So we're not going to graph these. We're just going to look at our slope and our y-intercept. Our y-intercepts are different. So these lines are what? They're parallel. And so they have 0 solutions. They never cross. And that's our answer. And I can just sketch it for you. I'm just going to sketch this for you. In one case, our slope is at, or our y-intercept's up here at 8. And in the other case, our y-intercept's here at 1. And these are both have a slope of -1. Okay, so you can see they're just parallel lines. All right. Let's do B. Okay, B is, let's rewrite this. 6y equals -3x plus 9. Divide everything by 6. And we get y equals -1/2 x plus 3/2. And so what do we have? We have a slope is the same, and the y-intercept is the same. So we have the same line, right? These guys both have a y-intercept at 3/2, and they both have a slope of -1/2, down 1/2, down 1/2. They both have kind of a narrow slope down to the right. So these have the same slope, same y-intercept, so it's the same line. So we have infinite solutions because it's the same line. Okay, let's do the final one. Well, I can already, let's just convert this guy. We subtract x from both sides. Y equals -x plus 10. And here we get y equals, add x to both sides. Y equals x plus 6. Well, here we have our slopes are -1 and 1. We have different slopes. So there is one solution. So if we go about solving this problem, we can even find that one solution. Now that we know that there's one solution, we can solve it. If we can add down to do elimination, and we get our x's disappear, we get 2y equals 16. Again, we're adding x and -x gives you 0x. Y and y is 2y, and that equals 16. So y equals 8. And if x plus y is 10, then x equals 2. So these guys meet at 2, 8. We can test it here. -2 plus 8 is 6. And what do these guys look like? Just so I can quickly graph these lines. This first one has a y-intercept up here of 10, and it has a slope down to the right. This second equation crosses about 0, 6 and goes up to the right. So it does make sense. It looks like about 2, 8 is the right answer. All right, so we've kind of we've sketched our graphs. We've identified how we know whether a set of equations, a set of simultaneous equations, or a system of equations can have 0, 1, or infinite solutions, and how to identify that. But now let's say that you weren't doing these by graphing. I want to show you a different way of solving this to know the number of solutions in an equation. If you're solving by, say, substitution, now if you're solving by substitution or elimination. And these are the problems from the earlier page. So let's say I'm not graphing, I'm not looking for the slope, and I'm not looking for the y-intercept. I'm just trying to solve. So let's try this guy. Let's solve this guy by substitution. And remember, this guy had 0 solutions. So I better not find a solution here. Okay, so we have x plus y equals 8, and y equals negative x plus 1. So now I'm going to do substitution. So I'm going to take my y from my second equation, which is equal to negative x plus 1, and I'm going to substitute that in for my y. Okay, this is just standard substitution. So x plus negative x plus 1 equals 8. Keep trying to solve for x here. I get x minus x plus 1 equals 8. X minus x is 0 plus 1 equals 8. And I get 1 equals 8. Well, 1 doesn't equal 8. And so that is your cue. That is your clue. If you solve a system and you get a false statement, there are 0 solutions. Okay, so instead of solving this graphically, you solved it by substitution, but you end up with this false statement. That means there's no solutions. And remember, we've identified that on the earlier page graphically because we had parallel lines. We had the same slope but different y-intercepts, which also gives us 0 solutions. So here's how we do it by substitution. Now we're going to solve this guy here the same way. So let's solve this one by, say, we could solve this by substitution, but let's just do it differently. If we solved it by substitution, it would show the same thing, but I just want to show you how we solve this differently. Let's multiply this by 2, both sides by 2, we're getting rid of our fractions. So we get 2y equals negative x, right? 2 times negative a half is negative 1 times x, negative x plus 3. Now we're going to put our x and y on the left side because we want, up here we have an equation with x and y on the left and our constant on the right. So we're going to add x to both sides. So we get x plus 2y equals 3. And so we're going to pull this other guy down. Let's pull this guy down now. 3x plus 6y equals 9. So what am I going to do? I'm going to multiply this one. I want to just see if we can get rid of my x's. I can multiply the top one by 3. And the bottom one, leave it the same. We'll multiply it by negative 3 to make it so we can do a addition straight down. Negative 3x minus 6y equals negative 9. And on the bottom, we get 3x plus 6y equals 9. So now if we add them down, we get 0 plus 0 equals 0. We get 0 equals 0. We used both equations, added them together, and we get a true statement. So this means we have, if we get a true statement as opposed to a false statement, we get infinite solutions. And notice what would have happened. I'm just going to do this again. If what would have happened if we would have used substitution, I want to show you that we also get a true statement. So we're going to take this piece here and substitute it in up here. Y equals negative a half x plus 3 halves. We're going to substitute that in for this y. So we get 3x plus 6 times our y, which is now negative 1/2 x plus 3 halves equals 9. So do our distribution. 3x minus 3x plus 6 times 3 halves, cancel our 6, cancel our 2, make a 3 here, plus 9 equals 9. So 0 plus 9 equals 9, or 9 equals 9. So again, we get a true statement, which tells us we have infinite solutions. Finally, let's do this one. This last problem we know has one solution because it had different slopes when we did it on the other page. But let's just solve it normally. Let's just add down, and that will eliminate our x's. We get 2y equals 16, y equals 8. And then if we substitute our y back in up here, we get x plus 8 equals 10, or x equals 2. So our point is 2, 8. And we can check it on this other equation. Negative 2 plus 8 equals 6. 6 equals 6. Check. Good. And there you have it. Oh, we have one more problem, and this might appear on a quiz. Extra problem, bonus for those of you who are watching the video. What is the value of b if this equation contains the point 4, negative 2? So what does it mean for a line to contain a point? Well, it means that if 4, negative 2 is on the line, if you can plug it in to equation and make a true statement. So let's plug 4, negative 2, our x, y into this equation and see if we can make a true statement out of it. Well, 4 is x. So that's 4. 3 times 4 plus b times y is negative 2, equals 8. So let's see what value of b will make this true. 12 plus negative 2b equals 8. 12 minus 2b equals 8. Subtract 12, subtract 12. Negative 2b equals negative 4. Divide by negative 2. So b equals 2. And that's our answer. Let's just check it for fun. So the equation would be 3x plus 2, our b is 2, 2y equals 8. That's our equation. So let's make sure it contains the point 4, negative 2. Well, 3 times 4 plus 2 times negative 2, does that equal 8? Does 12 minus 4 equal 8? And the answer is yes. Boom. Happy cat. And that is the whole lesson for today. Again, the keys for today were, finding midpoints, and B, the number of solutions to system of equations. And with that, I will leave you until tomorrow or next time when we talk about day 8. So that was day 7. tomorrow's quiz probably will have a question like that last one. Be sure you know how to do it. And we'll see you, again, see you next time. Over and out. See you with day 8.